Jitter and wander. By definition, in the frequency domain, wander is jitter that is within 10 Hz offset of the carrier. In other words, very low frequency jitter, that is, jitter below 10 Hz, is called wander. If it is more than 10 Hz off the carrier, it's called jitter. As will be seen later in the PLL section of this presentation, it takes a very low bandwidth PLL to attenuate wander. In most systems, wander is not an issue because the system PLLs can easily track low frequency wander, enabling them to wander together. In hierarchically synchronized telecom systems, any difference in frequency between the clock domain segments are typically not significant, and the FIFO buffers can absorb any momentary discrepancies. With frequency differences so low, the FIFO does not need to be very deep. However, wander can accumulate for some systems, and the wander can eventually become large enough to cause problems. In the figure shown are two different systems. The first is a typical sonnet application that implements centralized timing with a very low loop bandwidth PLL to avoid wander accumulation. The second example is a synchronous Ethernet line timing application that can potentially allow wander to accumulate by virtue of the cascaded clock arrangement. Care must be taken when designing cascaded PLL clock distribution systems to take into account both jitter and wander accumulation. As a note, when evaluating cascaded clock devices, RMS jitter is not linearly additive, but must be added by the root sum square of the individual RMS jitters. More on this topic in later slides.